Good morning, students. You're on to grade 8 mathematics. We're still on bearing and distances, but today we're treating something rather unique. We're looking at three-angle bearing, or more appropriately, three-figure or three figures. Three figures bearing. All right, so what is it all about? And we're going to be using a practical approach. We'll take exercise 24E on page 217 of our reference text, the New General Mathematics, and I want to trust that what you have is the same as mine. Okay, now, exercise 24E. Let's look at question 1A. It says, for each of the sketch in figure 24.18 or 1/8, state the three-figure bearing of B from A. Three-figure bearing of B from A. Now look at the diagram. I remember telling you that when you're dealing with three-figure bearing, the reference is always to the north. The reference is always to the north. But when you're dealing with acute angle bearing, the reference, you have two referral points, the north and the south. I hope we have not forgotten that. Now, when you're dealing with three-figure, the reference point is the north, measuring the angles clockwise. I'll come again. The reference point is the north, measuring the angle clockwise. So this will give me this. Now the question says the bearing of B from A. When you hear B from A, it means the reference point is A. So that is where the north will be. And if you measure this angle like this, you are told it is 56 degrees. Now, when you want to write the bearing using three-figure bearing, it will be 0, 5, 6 degrees. That's why it's called three-figure. It must always occur in what? Three-figure. Starting with 0, 0, 0 to 3, 6, 0. That's the range. Remember from your elementary knowledge of maths that, or geometry, that the angle at a point is what? 360 degrees. And when you're measuring, you measure in a clockwise direction. In a what? Clockwise direction. So A will now be what? Bearing of B from A will be what? That one for this diagram. Let's take the second diagram, question B. I'll be fast so that we can cover enough grounds. I hope you remember the protocol for this class. Thou shalt not draw with a biro. Thou shalt not draw with a biro. Go and get your pencil and your ruler. Right, this is 120 degrees. That's 120 degrees. Now, the question is still the bearing of B from A. Bearing of B from A. So remember that we said that it is measured with respect to a reference north. Bearing of B from A means the point of interest is B. Now you're going to measure clockwise. We measure what? Clockwise. So from here, you measure like this. And for those who missed my class previously, let me give you a little guide. This is 0. This is 0.90. I want to tag in terms of three-figure bearing. This is 180. This is 270. And back to what? 360. So what that means is that any angle that occurs reference north in this axis to this point is 90, to this point is 180. So to get this one, you need to draw what is called an imaginary line. extend. In technical terms, it's called what? You extend that line. I'm giving you all of these. You may not find relevance for some of these things now, but later you will hear them a lot as you go higher in maths. I will extend this line down. When I extend a line, I use dotted this thing for that. So when I do this, this position becomes 180. I see that. Remember from your other elementary knowledge, this topic is built on previous knowledge. Angle on the straight line is what? 180 degrees. Now, if this is 120 degrees, what would this angle be? Can somebody help us? What would this angle be? If this angle is 180 degrees and this part is 120, what would this part be? Jeffrey, Miracle, what would that answer be? Beautiful, Alex and Alex, 60 degrees, that's correct. So 60 degrees. So you see that when we are learning, sometimes I will stress some things because I know where I am heading to. This is the mathematics cinematic universe, multiverse of mathematics. All right, so with that, to get this bearing, all of this now, you will add this 180 to this 60. So the bearing of B from A will now be 180, which will take you to this point, plus the extra 60 that will take you to where you are supposed to be. That will be plus 60, and that will give you 240 degrees. I feel like speaking like one of my fellow colleagues in school, Okwinanu Owe. You know, he likes to do that a lot, and anytime I hear that, I'm very happy. Sometimes we have to bring the learning to a local level. All right, let's go to C. Question C. So make sure you're making effort. Make effort, make effort. Don't just sit back and think you're watching television. Right. Okay. Okay, that's the question C. Please confirm if what Uncle has done is correct. Now you're told to find the bearing of B from A. The bearing of B from A. When they say bearing of B from A, the reference is A. So measure the angle on A. Look at it, not clockwise. It will be this angle here. So that will simply be what? 120 degrees. It's very easy. D. Look at this one. Bearing of B from A. The bearing of B from A. What would it be? Now, look at it now. Remember that thing I drew before? This is 0. This is 90. This is 180. They are discussing. Please focus. I can see you. This is 0. This is 180. All right, this is 0. This is 90. This is 180. This position is what? 270. Is that not? 270. So the angle is measured in a clockwise direction. Are you seeing that? And where does it land? It lands on the 270 degrees position. So your bearing is what? 270 degrees. All right. So look at everything. E, not in a hurry, because once you're able to understand these concepts, it becomes easy for you to solve problems by yourself. All right, look at E. You are given this angle, 33 degrees. This is north, this is A, and this is B. Now, the question requires that we should find the bearing of B from A. From A, the bearing of B from A. How do we handle that? How do we handle that? Quite simple again. Now, look at this. you discover that this angle here has gone a little above this position. Now, there are two ways you can solve this. You can either extend this line like this. I see what I've done. Because remember that the angle you are measuring is starting from north in a clockwise direction to this point. I see that. North, clockwise direction to this point. North, clockwise direction to this point. Or, so from here to here, at this point it will be 180 degrees. So angle on a straight line. Let's look for what this angle will be. What will this angle be? Angle on a straight line. This angle plus this angle will give me angle on a straight line. So let somebody solve and tell me what this angle here will be. Angle on a straight line, I have 33 and another angle. What will the other angle? So that will be 147 degrees. Now, this is method 1 because I'm going to show you method 2. You will now come here and say 180 plus 147. When you add that together, what does that give you? Daniel, beautiful. Umi, thank you very much. That's 327. All right, so that's the answer. But there's a simpler way to solve this. You know that angle at a point is 360. Is that not? Angle at a point is 360. So from 360, remove 33. What does that give you? That's the easiest way to go. That's method 1. Or you just simply say 360 minus what? 33. And what does that give you? That will also give you 327. And for me, that should be the best method to use. But the reason why sometimes I don't constrain you to a particular method is that you might forget a method. So you have forgotten the method. Doesn't mean you won't solve it. You must solve it. So that's why I don't constrain you that you must use a particular method to solve. Except where it's so important that you must use that method. I want to make the diagram very big. It's intentional. This is the point X. All these points, everything there, that's the point here is X, not the angle per se. This X means this point here. Let's pay close attention to this because this is the main work of today. Once you get this one, you have gotten the topic. Once you get this, you have gotten the topic. All right, once you are done with drawing, please let me know. This will be A, this will be B, this will be C, and this will be D. So once you're done with drawing into your book, let me know. All right. In this question, we are told to find the bearing of A, B, C, D from where? From X. So let's take it one at a time. The bearing of A from X. What is the bearing of A from X? That one is simple. Remember that for all these questions, you must understand that the reference position is what? X. The reference position is what? X. And it's always measured with respect to a north-south position clockwise. So look at it. So what's the bearing of A from X? It will be measuring this angle. I seen it. And so the answer becomes what? 040. That's why it's 3-figure bearing. Now, let's look at the next one. Let's call this Roman figure 1. Now, Roman figure 2, the bearing of N, X, the bearing of B from X. Now, how would you get that? I know some of you looking at the question, how do I solve that? It's very simple. Don't start the bearing of B from X, sorry. Now look at it. Look at B, look at B. I don't know this angle, but I know the angle that is opposite it. It's what? 60 degrees. What is this? The northern line is always a vertical line. This is 180 degrees, angle on a straight line. So to get this bearing, I know that I'll have to say 180 minus the opposite angle facing, which is what, 60 degrees. And what's the final answer? Can somebody tell us what that is? 120 degrees. Now, Roman figure 3. The bearing of C from X. Where is C? I see it. This is C. So it means that this is what you are doing. Please be drawing it to. Don't say you are waiting till I finish. If you wait till I finish, it will be too much. Confusion will come in, or will set in rather. Now, this will be equal to, how do I get C? I have gotten to what? 180. I now move an extra what? 50 degrees to what? C. So that will mean 180 plus what? 50. Opinion. All right, so that will give me what? 230 degrees. Roman figure 4. The bearing of D from X. The bearing of D from X. How do you do that? It means, look at it. I seen that. Now, if you look at that thing very well, this is the angle you are looking for. This is what your whole of this angle you are looking for. So angle at a point minus that 70. 290 degrees. All right. 290 degrees. Beautiful, beautiful, wonderful. So I guess you now understand that. So I'm trusting that any question you see that is like this, you'll be able to handle it. Now, the next thing we're going to look at now will be, we'll try to solve a problem where we have to look at the bearing from different directions. You know, we have been looking at bearing of what? C from X. What about if we are told to find the bearing of what? X from A. How do we do that? Okay, now, to help you in this area, I'm going to remind you of something you were taught earlier. Have you heard of parallel lines before? Just answer in your mind. Just try to prepare your heart for what you're going to see. Have you heard of parallel lines before? Do you know the type of angles you can get with parallel lines? Corresponding, alternates. If you remember these, then you are set for the next idea I'm going into. All right, so let's go. So to help us in this concept, we'll look at question 5. Hope I got that right. Question 5 on page 218 of our textbook. Question 5 on 218 of our textbook. I'll just take one of the questions there, A, and I'll draw the diagram twice, and Or let me draw once and see if that will help us. These are northern positions. This is A. The whole of this angle is what? 250 degrees. So please be very attentive here because I'll be playing with a lot of ideas from geometry and trigonometry here. So let's be very attentive. So once you're done with your drawing, let me know. Now, this means that this line is parallel to this. So the northern positions are always parallel to themselves. So this line is parallel to this. Let that be stuck somewhere. This line is parallel. Now look at this. Now, there are two questions there. Roman figure 1. Okay, that's what I wanted to do. Roman figure 1 and Roman figure 2. I wanted to keep the questions side by side. It says the bearing of A from B. That's one. The other one says the bearing of B from A. The bearing of B from A. Now, please, when you read the question, your first objective is to identify the reference point. Once you hear the bearing of B from A, the second thing is your reference point. Don't begin to break your head and begin to analyze. Once you hear this from, the bearing of B from A, the reference point is this. The bearing of A from B, the reference point is this. Now, for this one, I will come here. I see me. This is A, this is B. I will just come here. I hope I'm correct on that. Yes. I will come here and read the angle. The angle will be what? Like this. I seen it. So this one clearly is 250 degrees. Say go be. Don't need to waste time here. Now, the bearing of B from A. This is the reference point now. So what you need to do is this angle. Look at it. Look at it. So please watch. I'm going to give you a very fast way to solve this. I noticed that in modern mathematics, they don't mention something. And I'm trying to ask myself, why is that? There's something we call allied angles. I wonder why they don't mention it today again in modern maths. I've queried that for some time. Allied angles. Allied angles are supplementary. Supplementary means that they sum up to what? 180 degrees. The concept of allied angles is a concept that if I have two parallel lines and I have a transversal, this is a transversal line cutting or joining the two parallel lines, this angle plus this angle must give me 180 degrees. I'll come again. This angle here. Let me get my colored marker so that I can drive home that point well. Now look at this. Please watch. I want you to understand the concept. Now look at this. The concept of allied angle is saying that this angle here plus this angle here, if I add it together, I should get 180 degrees, provided this line is parallel to this line and there's a line connecting them. Let that sink. I wonder why we don't use that again. I've checked modern teachers, they don't mention that. And that's the easiest way to understand this idea. So I've gotten here to be what? I've gotten here to be what? 200 and what? 50, is that not? 200 and what? 50. So angle at a point, I can get this angle. And that will be what? 360 minus what? 360 minus what? 250. That will give me what? 110. Is that not? 110 plus an angle I don't know will give me what? 180. So this angle will be what? 70 degrees. Don't worry, you're watching the video after now, so you will take time to understand. That's one approach. But what I discovered modern teachers do is this, and that's the one I want to show you now. Maybe that will be better for some persons. They use the concept of alternate angles. Now, if I drop this down, at this point it will be 180 degrees, which means that this angle here will be what? At this point is 250 minus 180. 250 minus 180 will give me what? 70. So this angle is 70 degrees. Alternate angles, this becomes what? 70 degrees also. So the bearing of B from A becomes what? 70 degrees. So I've just, in a very quick one, I have done two methods. So I will require that you go back. Since I'm providing the video for you, you watch the video again and then attempt the remaining exercise. For your classwork, I want you to look at exercise 24E, is voiced, so you hear this later. Exercise 24E, question 5, do B to G.